Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Welcome to episode number 69 of the Reliability Matters podcast. I was privileged to recently be a guest on the Pick Place podcast with Chris Denney from Worthington Assembly and Melissa Hough from CircuitHub. This is the second part of a two-part interview. It's kind of a podcast within a podcast. I spent 2 episodes answering questions about cleaning post-reflow circuit assemblies, stencils, cleanliness testing, and IPC's new cleanliness testing and cleaning process control standards. Here's part 2 of the 2-part series, my conversation with Chris and Melissa about cleaning.
Welcome to the Pick Place podcast, a show where we talk about electronics manufacturing and everything related to getting a circuit board into the world. This is Chris Denney with Worthington.
And this is Melissa Hough with CircuitHub. Welcome back to the show. This is the second part of our conversation with Mike Konrad of Aqueous Technologies. In the first part, which we recommend checking out first if you haven't listened to it yet, we talked about the history of board cleaning and why someone might want to include board cleaning in their process.
But now I want to talk a little bit about the how, because with organic acid, I think the how is fairly straightforward. This is a water-soluble flux. Salt is water-soluble.
It's not as straightforward as you think, Chris.
Okay, so this is what I was hoping you might say. Go for it.
Yes, the flux in the best of conditions is totally water-soluble. So one would think, just run water. Remember what I said earlier. There are a bunch of what I call usual suspects that are also on the board. Usual suspect residues.
Yeah.
Board fab.
That's right. Yep.
Component fab, Doritos, humans, salt, moisturizers, sanitizers, you name it. Oils from various conveyors, all that. And residue species fall into 2 categories. 1 or 2. They're either polar, which is soluble in water, or they're non-polar, which is non-soluble in water.
Okay.
Your flux, water-soluble flux, organic acid flux, is polar. It's coming off, not always, but sometimes it can get burned on if your profiles are wacky. But generally, it's going to come off just with water.
You got to be doing something wrong to burn it on.
Exactly. But we've seen it all, right? We've seen it
sure.
all. But generally, it'll come off just with water. But what about all the nonpolar stuff? Because I guarantee you it's on there. Because the process residues fall into those 2 categories. So if one only uses water, in the old days, that was fine because the process residues were lower than the tolerance because the tolerance was huge because components were miles apart. But today, because the tolerance is extremely low due to miniaturization, standoff heights and all that, just the usual suspect residues might be enough to trigger a contamination-caused failure mechanism. So that means that when one cleans, best practice would be to clean everything, not just the flux, clean everything.
Right.
Yeah. Right.
And I always recommend, even though we make machines, and every company makes machines that use only water, it's our least popular model. I think best practice is to use a chemical additive that allows you to remove both polar and non-polar substances, water-soluble and non-water-soluble substances. That is best practice.
We do not have any plans to use organic acid because I don't, how do I put this? I don't like being held down to a time.
Right. It's like that Mission Impossible tape. This tape will self-destruct in 30 seconds. And
exactly.
Yeah.
It's like, I remember, being a teenager and working at this contract manufacturer, and all we used was OA. And it was like, my time to go home was 5 or 5:30. And then somebody would rush in and be like, "Oh, hey, I just did this rework." And it's like, okay, now I got to, because I was washing boards. That was kind of my job, is to put them through this inline cleaner. All right, now I got to stay here another 20 minutes while I deal with, it was stressful to know that you had to get this thing cleaned right away. Although organic acid fluxes are really, really nice. They're incredibly powerful fluxes.
Yeah.
But now in order to clean rosin style fluxes, either RMA or no clean fluxes, that we definitely have to have a saponifier, which is just, it's what big grown-ups like to call soap, I think, basically. A special type of soap. Am I right?
Yeah. What a saponifier does is it runs a process called saponification. So you have the acids in the flux. Rosin fluxes are acidic. And then your typical saponifier is got a higher level of pH. So to be able to use water to remove a non-polar, a non-water soluble material, we have to convert it to soap. So what it does is basically it's a battle of pHs, and the result is soap, and the soap can be rinsed off in the rinse process. But most of the modern chemicals don't rely totally on saponification. They have aqueous blended, I'll say alcohols as a placeholder. The chemists in the world will go, they're not alcohol, but they're basically aqueous blended alcohols that will also solubilize the soils.
Is it like just typical ethanol kind of stuff, or is it something different? No,
that wouldn't be. That's not mixing with water. It's beyond my pay grade, and I should know this because we work with the chemical companies very closely. But it's a combination of saponification and solubilization that allow the soils, both polar and nonpolar, to go into solution. So cleaning is a multi-stage process. First, you wash.
Yes.
And washing does not make your board cleaner. It makes your board actually dirtier because it takes all the solution and puts it into, it takes all the contaminants and puts it into solution, as well as all the other solution that was from prior cycles.
That's right.
But it does, it does solubilize the material. And then the most important, the most critical cycle is rinse. After the boards are washed, they have to be rinsed. And that's where really critical. Get rid of the wash solution.
Think of it this way, Mike. I think a good illustration for this is, imagine washing your hands. Like, okay, you rinse your hands a little bit with water, and then you get the soap on your hands and you rub the soap all over your hands. And then do you just walk out of the room?
Nope.
No, your hands are disgusting. Absolutely. You got to rinse them.
Absolutely. And your skin will burn over time if you don't
that's a good point.
Remove the soap. And the same will happen with a board. If you are using a 10 or 11 pH saponifier and washing your boards and you don't properly rinse it.
Oh, because that's right. Because the flux is an acid.
Dull,
that's why you have a high pH.
You'll end up with black solder joints, which customers don't really like. So don't give your customer any reason to inspect.
No.
If they see something, it could be totally benign, but if they look, what do? They find, right? And then they're going to find everything, right? So
the best is when we get the reports back and it's like, I used a 40x microscope. It's like, well, you're going to find anything with a 40x microscope.
Exactly. Yeah. It's like they look, they find, and then they keep looking, and then you're suspect forever.
I appreciate you breaking down the general steps of cleaning. It is, basically some kind of soap and agitation, and then a washing, or excuse me, a rinsing. Now, my understanding is, and what I'd like listeners to understand is, there's really kind of, in my mental model, there's really kind of three processes for cleaning. There is the old school bucket and a brush, right? Which hopefully nobody's doing. But it's more or less, you get the soap on there, you get the water on there, the soapy water. You get the agitation from a brush or something else, and then you have a rinse.
It's really a 3B system, Chris. It's a bucket and a brush and Bob. And
that's right.
Bob is the one that determines if the bucket and the brush are produce a successful result. That's the problem.
Well, in our case, it's Brad. It probably wouldn't be
Brad.
Bob.
Bucket, brush, and Brad. Right.
Yeah.
If Brad's having a bad day or has a hot date on a Friday night, those last boards aren't coming out clean. I guarantee you.
Yowza, Brad. Yowza.
Slow down, Brad.
So, funny story. We do have a Brad who works for us, and I always tell Brad, I go, you know how you hear these stories of so-and-so, it'll be on the news, Lester Holt or something will say, so-and-so died today. And it was revealed that they were one of the leading scientists on the Manhattan Project, or some, right, super secret thing that they could never talk about. And then they died and it was revealed. And I'm like, Brad, I am convinced. I am absolutely convinced that you have some like, because the guy's just brilliant. He's like off the charts. And I'm convinced that he has some like secret past where he was, maybe not Manhattan Project, because that's way too old for him at this point, but there is some special project he worked on, the GPS satellite system. Sure. He was allowed to, the spy planes over Russia. I'm convinced Brad was involved.
Yeah.
We'll find out. It'll come out.
Hopefully not for a long time, but it'll come out.
But that's the kind of guy, that's the kind of guy Brad is, just completely nondescript and just a hard worker and focused. But anyway, it just cracked me up. Okay, so we got the 3 Bs. We got the bucket, the brush, and Brad.
And Brad's the deciding factor.
He's the deciding factor.
You don't want Brad. Sorry, Brad. You don't want any Brad or any Brenda to.
Yeah. Oh, we have a Brenda. We have a Brenda.
There we go.
Yep.
See, it's all fair.
Yep.
To be the deciding factor on what's clean and dirty.
You're absolutely right. So we are humans, and we are great innovators, and we've come up with means of measuring soil content in fluids, which is, I think, what you're getting at. We have, after your Brad, bucket, and brush, we have for my limited understanding. And please, I realize this is such a ridiculously insulting understatement, but you have kind of the dishwasher method. Let's call it a batch.
Let's just get the D word out of the way, Chris.
All right.
It's fair.
It's batch cleaning.
For years, I was totally offended by the whole, not a dishwasher, because we go to a trade show and people go, "Can we put our lunch dishes in it?" Just, you hear that over and over and over again.
Oh, you know how many people want to put pizza in my reflow oven?
Exactly.
Yeah, all the time.
Or whatever.
Yeah, so, Melissa's definitely one of them. So that's kind of a batch cleaner.
It's a batch cleaner,
right?
Yeah, it's a dishwasher type.
And then there's also your inline cleaners,
which I like to call conveyorized, by the way.
Conveyorized. That's a better way of putting it.
Why?
Because you usually don't put them in line.
Perfect. Very few people realize that. I will show 100 pictures of whenever I go through plant tours and stuff. I'll, with permission, I'll ask if I can take some pictures just for my workshop purposes. And whenever I see an inline cleaner, so-called inline cleaner, it's not in line with anything.
Never.
It's a 23-foot batch machine. Only the difference is Brad or Brenda is now running 23 feet from entrance to exit, all day long, right?
In my case, it was just one teenage kid and another teenage kid. One fed it and one unloaded it at my old shop in Jersey. But the my understanding is the conveyorized systems are more for speed. Both of them are going to get the job done. I am not aware of anybody, and I would love to know otherwise, because I think it's super cool if they're able to do it, using a conveyorized machine with anything but organic acid. Like I've never walked into a shop and seen a conveyorized machine and gone, "Oh yeah, we're clean and no clean with that machine."
Particularly in the older days, it was almost all water only.
Okay.
Now, for reasons that we've already reviewed, a lot of people are catching up to the fact that they need a chemical for all the other usual suspect contamination species that are on the assembly. And that's where it gets really tricky. There's a couple of misnomers. I talked about conveyorized machines. One is that they're rarely in line with anything for logistical reasons. The second is that they are faster. Well, the move from eutectic, from leaded alloys to lead-free alloys kind of changed that. And the use of chemicals in most cleaning processes also changed the speed. And the tight tolerances, the little 2 mil standoffs we have to get under a BTC with, have also affected the speed. So the average
bottom terminated component for those listeners who don't know.
Bottom terminated components, made by invented by a young engineer whose parents never told him they loved them enough, because he decided to get back at the world with the introduction of bottom terminated components.
I love bottom terminated components. I like, as from a manufacturing perspective, they're so easy. They're so easy.
But from a residue perspective,
they're not.
Voiding.
Yes.
You can't get, unless you have some very expensive vacuum reflow technology. You're not going to get zero voiding. IPC knows that. They said you can get 30% voiding. The problem with voiding is we hear the word void, we think there's nothing in it. It's only void of solder. Guess what it's filled with?
Right.
flux residues, right?
Yes.
That's what's causing the void. And that's
right.
very problematic from a contamination standpoint.
It ain't air. I know that much.
Air, exactly.
No.
It ain't air. It's bad actor, unactivated residues from no clean that aren't going to be problematic. Anyway, I'll go back to where we were. The average inline speed, conveyorized speed, used to be 4 to 6 feet per minute back in the day.
Whew.
4 to 6. I mean, it was a race car.
That's hauling.
The average speed today is half a foot per minute.
Oh, I definitely turned that up, by the way, because like once the boss went home at the end of the day, I was like, I am not sitting here all day.
The
absolutely. Yes. I was like, this is ridiculous. I can feed these things faster than this thing can take them.
Yes.
Crank that bad boy up.
Well, the average conveyorized length, the average conveyorized cleaner length is 23 feet. That's average.
Okay.
Some are a little.
Sounds about right.
Some are smaller, some are larger, but 23 feet. So imagine people like, I need a conveyorized machine for speed. Put your first board in at half a foot per minute. That's 46 minutes before the first board even pops out the other side.
Wait, we're down to half a foot a minute
That's
now?
the average speed today, half a foot a minute.
Wow.
Yeah.
Holy!
No, there are exceptions to that. You're going to have some of your listeners are going to go, wait a minute, we're running 3/4 of a foot a minute. Okay, fine.
Yeah, sure. All right. Well, you're
let's
still.
assume it's a foot a minute. Let's assume I'm off by all that. It's still 23 minutes before the first one even makes an appearance, but half a foot is pretty common right now. And if you have a larger machine, you can run faster, but you've got more space to travel. So
that's right. It's like a reflow oven.
Yeah.
It's very like you buy a big, giant, long reflow oven because you want to put a bunch of boards through it quickly, not because you think it's going to be able to handle the thick boards. A small reflow oven will handle the thick boards.
Right.
It just has to do it slower.
Well, there's two things you need when you buy a conveyorized cleaner. One is space and utilities and DI tank farms and all that. You need all that. And you also need a sign to put in the parking lot to reserve a parking space for your chemical salesman. Because
that's what I was thinking.
Because they are chemical hogs. And
that's exactly what I was thinking.
If they never turn off. If you're just running production, and board after board after board after board, who cares? A Greyhound bus gets probably 4 miles to the gallon, but you have 68 people on it, right?
Yeah,
so
that's right.
It works out. You would not take a Greyhound bus to take 3 kids to soccer. You would take a minivan to take 3 kids to soccer. It's just efficiency. However, there's still a mentality left over from legacy that I got to buy a conveyorized cleaner. I don't want a dishwasher. I got to buy a conveyorized cleaner. And what they don't realize is, they take an hour to warm up. They take a huge amount of space. They usually require hearing protection or noise abatement kits, either way. And the average, if you run it just 8 hours a day, the average chemical consumption is around 70 or 80 grand a year. You're going to pay for 3/4 of the machine year over year over year over year. So
that's when trying to clean no clean, not organic acid.
That's running a chemical, right? So which one should do on anything? But yes, running a chemical.
But perhaps you could get away with a bit less if you were doing organic acid.
Yes, that's true. You can run. Yeah. When I say 70 or 80 grand a year in chemical costs, I'm assuming a 15% chemical concentrate, which is pretty typical. 10 to 20 is typical. So say 15.
Okay.
If you're running an OA flux, you can probably get away with 3 to 5%.
Okay.
Because you're not having to saponify the flux, which has gone through an oven, which has been baked, and it's hard to form channels, irrigation channels through them and solubilize them. The other residue species are a little easier to come off with lower percentages.
Okay,
so it would be lower, but conveyorized machines have their place. We've sold conveyorized machines for years, off and on. We've had a love-hate relationship with conveyorized machines. And then, now all we deal with is batch, but not because for any other reason than, we just really believe batch. And I'm not promoting our company. Any company that builds batch machines, I think, are on the right track because they are incredibly efficient.
Well, right.
They don't have that huge chemical cost. In fact, your salesman will probably, your chemical salesman will probably never visit you. You'll probably never get a free lunch out of it because it's not worth it.
It is interesting to me because when we first started talking to cleaner manufacturers such as yourself, I really didn't understand. I really sincerely and deeply care about the earth and the environment and the impact I have on it. It does matter to me. And I realize it's a bit it can get into a bit of a political territory, and it can get controversial. But as much as possible, I think if you can make a decision that is good for the earth, it tends to be also a good financial decision. Like if it works for you, it can be a good financial decision. So for example, I plan on buying an electric vehicle pretty soon. We're closing on a house, but after we close, I'm probably going to buy an electric vehicle. And I'm doing the math on it. And it's like, if I spent, this amount of money on an Audi, with a gas engine versus this amount of money I'm going to save money because it's so much cheaper. I could put a solar panel on my roof and like basically have free fuel more or less for my electric vehicle. And looking at my commute and then like I looked at all of the, oh boy, I'm going off on a huge tangent here. But if you look at the effort to create a battery, yes, it's extremely carbon intensive to create the battery that goes into these vehicles, especially a high mileage vehicle like a Tesla or something. But then because
you're the battery one time,
right? Because you're not burning the fossil fuels.
You're not creating a battery in the form of 20 gallons of gasoline.
That's right.
Every week.
So after, but I think it's like 16 or 20 months or something like that, based on typical mileage, you end up, it ends up being beneficial for the earth. And I was surprised to find out that a lot of companies such as yourself, these batch machines that they're making, they are remarkably efficient in, like you were saying before, compared to the conveyorized machines, remarkably energy efficient, remarkably water efficient. I was expecting to have to like tank out 55-gallon drums every week. Oh. And, like I had no idea. And like, no, why would you? That's ridiculous. It's all self-contained. Like I'm thinking I got to get plumbing and I got to get drainage and I got to, because we've had the Department of Environmental Protection in, Massachusetts Department of Environmental Protection in. And, they just want to make sure that our waste stream is proper and we're all lined up and we got all that set. And we do have a nice process for that. They helped us out with that. And that was one of the things that I was concerned about with cleaning is, here's something that is just, in my opinion, is a pollutant, right? This is what I had in my mind. Sure. If I start cleaning everything, I'm just going to become a giant polluter. And I was really surprised to learn that is not necessarily the case. And I hope you can kind of speak to what goes in, what is the process of reclaiming the chemistry, reclaiming the water, and being efficient, because that will set my nerves at ease a bit about jumping into these waters.
Sure. Well, one thing that we preach regularly, you don't want to solve one problem by creating another.
Right? Exactly.
So if you have a reliability issue on a board, it's failing because of electrochemical migration, dendritic growth, parasitic leakage, all these things that contaminants can cause on a board. You don't want to solve that problem at the expense of the local water district walking up your pipes and citing you. Right?
Yeah.
So, it's not a pick your poison. You can have both. We are big believers, and this is going to sound a little voodoo crazy when I say this. Maybe it's my...
Where's my tinfoil hat?
I got to get your tinfoil hat on and filter out the microwaves that are going to come from this statement. We believe at our company that we need to do something bigger than ourselves.
Yes. Right? I believe that as a human being.
I do too, but particularly we bring that into the company, and some listeners are going to go, "Oh, this guy's kind of crazy," which is fair, right? We are, but we believe that we need to make the world a better place. And how can we do that? How can you sell dishwasher type circuit board cleaners and claim you're making the world a better place? Well, environmental. So we made a decision several years ago that we're going to start producing equipment, and this is not a commercial. I think other companies do this too, and if you got no plugs out of this, I would be doing you a complete disservice. So you got to brag a little bit. Well, that's right. Yeah. Ass company. Yeah. No, we want to make sure that we don't ruin the earth trying to make products more reliable. We don't want to solve one problem and create another. So we started building zero discharge equipment.
That's a great point. Yeah.
Zero discharge. Okay. Not a drop of fluid goes to drain. And they cost a little bit more, not much, but a little bit more than the machines that do put some stuff down the drain. And we thought, well, let's see where people go. We'll still give people a choice, but let's see where people go. probably 75% of our products now are completely zero discharge. And we actually calculated it. I'm a marketing guy by heart, right? So I love marketing, although that's all morphed over the years. But I figured out how many 5-gallon water bottles that you would have on a water dispenser. How many of those could we line up based on how much water we've saved in 1 year? Just us.
Oh my goodness.
One company. That's just one of many. And we can go from here to Dallas. It's standing up, not over the side, standing up vertically. Water bottles, these 5-gallon water dispenser bottles. We can go from here to Dallas with the amount of water that just one company, just our company, has saved the earth in 1 year. And
that's awesome.
So all of a sudden, our little company in a small company in a big space made a difference, and and it's tangible, right? That's a boatload.
That's
of water,
a real
right?
Yeah.
I shouldn't say a boatload of water. Boatload of water would imply the boat sank, but
that would be
But
that'd
anyway,
be pretty bad.
wrong term. But that's a lot of water, and not just that.
It's a pool. That's a pool load of water.
It's a pool load of water. In fact, I think we calculated it's 86 Olympic-sized swimming pools or something to that effect.
Holy moly!
It's a lot of water. And not just that, our customers don't have to get a discharge permit. In many regulated areas, like yours, certainly California and mine, if you want to put stuff down the drain, it might be totally legal, but you have to register.
Okay.
And the way it works, at least in California, if you're a registered polluter, it's, and I can't speak from experience, thankfully, but I would imagine if there is a contamination found within 50 miles, I think in California, 50 miles, they will come into your building. And just like the example of we don't want customers who put a 40x scope over your boards, over the products you sell them, we don't want that 40x scope coming in from an inspector, because what happens when they look? They find. And it may not even be what they were looking for, but they generally, they figured, look, I drove all the way out here. I got to find something. Right, exactly. I got to make my boss happy. So if we can just keep our customers from having to even request a discharge permit, there's 1,000 other things that can put them out of business, but it won't be this, right? So
how is that, like, how is that possible? I guess like you can't get something from nothing. Like you can't squeeze a rock and get water.
It's good engineering. We redesigned the machines to allow it to be zero discharge. And so the wash solution, right? That mixes with the water and it's used over and over and over again. But every time you use it, you lose some, because some gets dragged out into the rinse and some goes up the stack because it's heated, right? So some evaporates. And that creates a very beneficial level of attrition.
Oh,
you're adding more.
Kidding.
You're adding more. So I have a swimming pool, and I have never ever changed. I shouldn't say never. When I had to resurface the pool, I had to take the water out, but I never changed the water in the pool,
right? Because
I filter it, I keep it in chemical balance, I check the pH, and I have a autofill that adds more water as it evaporates, particularly in the summer. So this is the same reason why in a cleaning system that is a tiny bit loose in the wash side, meaning you're going to lose a little and drag out to the rinse. You're going to lose some due to evaporation. So you're going to be constantly adding, you're going to be keeping it in chemical balance. And chances are it will not load up as fast. In many cases, it never gets fully loaded because you're turning it over slowly.
Sure.
In some cases, it can get fully loaded, in which case you have to put it in a drum and haul it away as waste, but it doesn't go down the drain. Right. And in the world of waste, it's very clean waste, but that's another story.
All right. So sometimes you do need to, you will run into a circumstance where you have to, you'll have to bin something. You'll have to take something out of the building in a bin so that you don't put it down the drain. Are we talking about the filters? Are we talking about the water, the dirty water? What is sometimes getting drummed and taken out?
Yeah, in less common cases, but it does happen. You might have to drum up your spent wash solution.
The wash solution, not the rinse. Okay.
The rinse water, no. But the wash solution might have to be, but in most cases it doesn't have to be. It's just turned over, kept in the same swimming pool analogy. Don't change the water in the pool. Just keep it in concentration. Keep it in check. But it could happen. And that is like a total of 12 gallons every month or two, if you had to remove it.
If you had to.
The other is a particle filter, which is used to capture anything like solder balls or inspection.
Yeah, you're going to have solder balls and
terminations that fall off the board. They'll get into a particle filter. And if technically there's solder balls in there, then that's technically hazardous waste.
Yeah.
But make a deal with your dross guy, and they'll be happy to take it.
Yeah, that's basically what we do, because we have like our stencil wipes, and we have just all kinds of stuff like that. And we have an arrangement with a recycler for all that kind of stuff.
They have the technology to pull the stuff out of it, and they'll melt it back down and sell it back to you.
Yes, that's true.
And then the other is a carbon and ion exchange resin tanks. That's what closed loops the RIN. So there's two closed loops systems within a completely closed loop cleaning system, batch cleaning. One is the wash system. And even on our open loop systems, on our low discharge systems, the wash is still closed loop. We never put wash solution down the drain as part of a cycle ever. To make a machine completely zero discharge, we simply close loop the RIN side. And that's where it gets tricky. Not everyone can do this. Oh, they can if they engineer it right, but not everyone chooses to engineer it this way. You have to take the RINs water and run it through carbon and resin media that you would rent, never buy them. Just rent them from Culligan or PureTech or whoever. The carbon removes the organic content of the wastewater, of the waste RINs water, and the ion exchange resin removes the ions in the water, positive and negatively charged ions. So you end up with deionized water. And so you run a RINs.
So the system is generating its own deionized water
from the tanks that you rent. That's it.
Because I'm figuring I'm going to Walmart and buying gallons of DI water or something.
Walmart would only sell distilled water, but
distilled. That's right.
That's not good enough either.
No, sir.
Oh no. Distilled water. You put in iron, but you don't clean boards with it. And here's why. Deionized water is very hungry, right? It is even corrosive on certain metals like aluminum and things like that. Copper, brass, it'll eat it up because it's very hungry. It's absent of ions, and it just wants to leach everything it can.
Oh, no kidding.
Cleaning boards with it is not a problem. It's not in contact with the DI water long enough. Your boards aren't going to come out dull. But also, even more importantly, batch format machines, most of them anyway, allow you to test for cleanliness during each RINs. And how do we do that? The water that's used for rinsing is high resistivity. It's got 1, 2, 3, 4 million ohms of resistance, right? It's coming out of the tanks at 18 million ohms. By the time it gets stirred around and it absorbs CO2, it's probably 1 million ohms. So let's just say 1 million for the sake of discussion. So you're rinsing your boards with 1 million ohm water, highly resistive. Well, what are you rinsing? You're rinsing off the wash solution, which contains all the soils. That is highly conductive, extremely conductive. So here comes our 1 meg water up here. I'm saying up here, no one's watching, but raising my hand. And then it's mixed with the highly conductive material. So the resistivity drops down to virtually zero. And then the next rinse happens. Comes in again at 1 meg ohm and drops maybe to 10,000 ohms. And then the third rinse happens. Comes in at 1 meg ohm, drops maybe to 300,000.
Okay.
And then the fourth rinse, it's 600,000. And then the fifth rinse, it's 1 million, whatever the number is. So every time I run a rinse, the resistivity of the rinse water drops less. So what one is able to do is program on your recipe, where do I want the rinsing to stop? Do I want it to stop at 500,000 ohms, 700,000 ohms, 1 million ohms, wherever? And that doesn't mean the boards are clean.
That's right. I was just going to say that.
It means that
the rinse water is clean.
Right. So one can get a false positive if they rinse, if they wash with water. Say they have a no clean flux or an RMA flux, and they wash with water only. They forget to, run chemical. Then the boards will be wet, but they'll still be dirty. And then you go to rinse, and the first rinse it'll pass because nothing soluble to go into the rinse water to lower the resistivity. So it is not a cleanliness test. It is a process monitoring tool. Right? So any cleaning company that says they're doing a cleanliness test,
right?
There are some cleaning companies out there that say they're doing ROSE testing, resistivity of solvent extract testing, in their batch cleaner using water on the rinse. It's like, A, water can't detect nonpolar materials, and B, which board are you testing? You're cleaning 40 boards at a time. I mean, is it going to over average?
Right.
And it's crazy. But
let me back you up here for a second, because I'm certain that many of our listeners don't know what a ROSE test is. And I only know ROSE testing as much as like I know how to prune a tree. Like I know that tree pruning exists, but you don't want to trust me to do it. You know what I mean? Help us understand, what is ROSE testing? I understand it's a new-ish standard that kind of the industry has come up with. Is that correct?
Yes and no.
Okay.
I know what you're referring to. So ROSE testing came out 40 years ago. It came out in the 70s.
Oh, it's newish.
Yeah, well, ROSE testing came out in the 70s. And then the folks at the standards governing bodies like IPC decided way back in the 70s, early 80s that we should come up with a standard when using ROSE testing. And that standard pass-fail was 10 micrograms of sodium equivalent per square inch.
Okay, so the criteria is relatively new.
Yeah, well, that came out in the 70s or 80s, 70s, I think. That's where they came up with the pass-fail.
Okay.
What IPC has finally realized, to their credit, is that pass-fail was probably a bogus number anyway.
Sure.
And because if you're building a pacemaker, are you going to be held to the same cleanliness standard than an iPhone? Really?
No.
One has a high cost of failure. One has a low cost of failure. One even arguably has planned obsolescence. The other doesn't.
Yeah, because if my phone fails, I am not a happy man.
Right,
so
but you're not going to
high cost of failure. No,
right,
I know.
Right. It's a high frustration factor, but you'd be more frustrated if your pacemaker failed, right?
Yeah.
So
yeah.
As you fall to the ground, you'd be quite frustrated. So
that would be very frustrating.
So the IPC in 2018 revised the cleanliness testing standards.
Okay.
ROSE testing, resistivity of solvent extract testing, which formerly was a pass-fail for cleanliness, is no longer used as a cleanliness test per se. It is now required to be used as a process monitoring tool.
Okay.
And so now, instead of IPC saying, Chris and Melissa, your board has to have a 10 or less. What they're saying, Chris and Melissa, is you need to run surface insulation resistance testing. You need to set up your process. You need to prove that your board will not fail after so many hours under heat and humidity based on SIR, surface insulation resistance. And then, if you can prove that your board did not fail after 500 hours, 1,000 hours, whatever it is, of testing under heat and humidity conditions, take that board and put it in a ROSE tester and see what that number says. If let's say that number says 3. As long as you keep getting a 3, you don't have to do anything else. Keep shipping your product. But if you got a 4 one day, you need to stop the presses. Well, you need to test another one, technically. Test 2.
Sure.
If you still get a 4, you need to figure out what went wrong until you can bring it back down to a 3. You only have to do the process qualification one time, which is SIR under heat and humidity. And then you rely on the ROSE tester to make sure your process hasn't changed. So your ROSE tester is not saying your boards are clean or dirty. Your ROSE tester is saying nothing's changed since you've demonstrated your part will not fail if you get less than this number.
How does somebody like me who's building 5 of this and 10 of that possibly, because I don't have all day to put my customers' boards, each unique build into a test chamber with the proper temperature and humidity and then put it in a row. Like if I have a customer that says I want clean boards, there's no way I could put their board through all that testing to confirm that it's passed the ROSE test.
You do a test board. You don't use the actual board. You use a test board because you can't do SIR on a production board because it doesn't have all the comb patterns in it and all that. So you do a test board similar to it with similar components and reflow it with similar materials.
So there is a dummy board out there that we could build,
like a B52 board or something else similar. that has, you put the same type
they wrote great music, man. I mean, I don't know if I want to put that in
Love Shack
in a test chamber. Okay, so you are not testing production boards, you're testing your process.
You're testing
That's
your process.
What you're testing.
And if your process, if the ROSE tester, the resistivity of solvent extract tester, and those are, ours is 0 ion, there's the omega meter, the ionograph, the Gen 3.
I used to sell the ionograph.
Whatever name that is. Yes, they all, I mean, once you get into the minutia, some will say this is better than that, ours is better than this, theirs is better than that. But they're all ROSE testers. They all perform a very similar function. Which
a ROSE test is one board, one bath.
Yes.
It's not a batch process.
No, you wouldn't want it to be, because what if one was exceptionally dirty and the rest were very clean?
Right.
All of them would have a little bit of contamination.
That's right.
But you want one, if possible, one board at a time. And the only exception to that is if you have boards the size of a dice, half inch by half inch.
Yeah.
Then if you just test one of those in a big solution, you're probably not even going to see it, right? So you might have to add, enough to get a decent amount of area. But generally speaking, in the real world, one board at a time.
Well, you know what they say, Mike. The solution to pollution is dilution.
That's right.
Yeah,
that's right. That's common in our industry. Yeah.
So my test board is going to be half an inch by half an inch.
Exactly. Clean. Look at this. It's clean. As he wipes the Dorito dust off onto his shirt.
Oh, it just went up.
Yes, exactly. So that's how
interesting.
Boards are determined to be clean. And your question is spot on. It's a great question about, well, what if I'm doing 5 of these and 10 of these for my customers? How do I comply? Fortunately, IPC also has, at the end of every declarative statement, like, you must do this.
Yes.
It still allows, subject to agreement by the customer. You can always do, we've agreed to do it this way.
That's right.
And that will comply as well, as long as both sides agree. The purpose of ROSE testing is just to make sure nothing's changed in your process.
Yep.
Every day you get it's kind of like the sonar operator on a submarine. They hear this ding. What they don't want to hear is ding, ding. They don't want to hear it coming back, right?
Uh-oh.
They don't want to hear it coming back. So basically, ROSE testing is like that. You just ROSE test, you get a 0.2, a 0.3, a 0.1, a 0.4, a 0.2, a 0.3, and then you get a 5. And then you go, whoa, that's the responsive sonar thing. That's, all of a sudden there's something big next to you, right? You got to stop the presses and see what's wrong.
Now, is this something you're testing daily, weekly, monthly?
Usually one board per batch or one board per day. It's and very rarely some of our customers test every board. It only takes, if your boards are clean, it only takes a minute or two to test, maybe 2 or 3 minutes max to test a board.
Yeah.
So it doesn't really slow it down. But it depends. I don't like once a day, because things can go wrong during the day and you might not see it. And then you might have to quarantine more boards and repeat the process. I like one per batch.
We've become experts at quarantining now. I mean, like, you talk about
true. The whole world has.
We know how to do that now.
Yes, absolutely.
That's interesting, because we do have all kinds of process controls in place. And this is enlightening for me, because I did not know, other than just looking at it, how to control a cleaning process until this conversation. Yeah. So this has been very enlightening for me.
The cleaner should be able to control the process. That way you don't have the Brad effect. Sorry, Brad. You don't have the
we love Brad.
brush, bucket, and Brad, right? Now you have the machine and Brad. And if Brad, as long as Brad doesn't change the recipes, and in most manufacturers have password protected, recipes.
Sure.
If Brad really wants to get out early Friday night because of that hot date, and he throws twice as many boards in the chamber, right, as he should, because he really wants to skip that extra cycle. Yeah. The machine will automatically say, "Wow, there's a lot of contamination. We're just gonna add more rinses until we get to that number." So Brad really won't have saved a whole lot of time by doing that, and that way it takes it out of the operator's hand. And because cleanliness is so tied now to reliability more than ever before, that even when we cleaned every board, we probably didn't even have to.
Yeah.
In theory. Today, cleanliness and reliability are so close that we don't want to leave reliability up to a person. We want to leave or trusting the process, trusting they'll follow the process. We want to make it as airtight as possible. And that's why I like batch format type machines. Our brand, any brand, I'm only half sincere when I say that, but the point is, the batch technology allows that type of testing to go on and process monitoring. An inline machine can't do that because the conveyor is always moving at the same speed. And if a board is tested to be dirty, it can't just like have a robot arm pick it up and move it back and do it again, right? So an inline machine, a conveyorized machine, you rely on the process, you rely on the testing, and you rely that nothing's changed upstream or at
I
the
see
machine.
Nothing. I hear nothing.
Yeah. You're very young to remember Hogan's Heroes.
I watched a lot of TV when I was a kid.
I guess so. Probably Nick at Night, right?
Yes, exactly. All right. So my head is swimming with questions still, but I think what I'd like to do is, if we could, I think it would be a good idea to summarize our discussion a little bit because we covered a lot of topics here. First of all, don't use trichlor. We can all agree on that.
We can't buy it anyway.
Yeah. Well, you know what? You can buy something though, because I had this customer in Connecticut who had a vapor degreaser and they were putting something in there.
The issue with solvents in general is every year there are more and more solvents that are on the hit list, right? So they all eventually rotate out. The issue is if you live in an urban area, I don't live in an urban area, but I live in a suburbia area of an urban area. So we have AQMD, air quality management districts, and all throughout the country there are air quality management districts. And when you have one, they generally regulate VOC emissions, volatile organic compound emissions, which basically are solvents, to 50 grams per liter. And that's a pretty low number. In areas that are known for pollution, like Los Angeles, we have our own special AQMD called South Coast AQMD, SCAQMD. And the folks that work there have a calculator on their desk, which only has 3 buttons on it. You ever seen a 3-button calculator?
Nope.
It has divide by 2 equals. So whatever the federal limit is, their limit is half of that, whether it makes sense or not. How
many times have you told that one too?
Many times. It doesn't go over in bars very well because someone has to be really drunk to, just not understand what I'm saying. Yeah. But basically, if it's 50 on the national level, it's 25 in those areas.
Okay.
Which means I have a theory that if it tastes good or cleans well, it's fattening or illegal. Right?
That's right.
And that falls into this category. So the solvents are problematic, and VOCs are not just solvent issues. The cleaners that Eric sells you and other companies sell all have VOC ratings, and you have to make sure you're running a chemical that is compatible with your regions. If they have a setting, if they have a regulation, you have to make sure it's compatible with that because you don't want to get into trouble with your air quality management district. Sure.
Yeah, and everything is adding to that. So it's like when they're measuring this, it's not. Are they putting sensors on your building, or they have sensors throughout the city?
No,
how are they?
They'll come in and they'll look at the SDS sheet on your chemical, and they'll see what the VOC content is. But just keep in mind that the VOC rules are at the in-use concentration. So it might have a VOC content of 400, but you only use it at 10%.
Right.
So.
Right. Yeah.
So you have to look at that. You have to look at what the in-use concentration is, and your chemical supplier can tell you that. And in most cases, it's not an issue.
This is crazy, Mike. Like the amount of technical details. I think this is one thing, again, getting back to the genesis of this show and why we do this show is to expose what it takes to get this stuff done. Because, for a long time, we've had people say, well, why can't you just clean my boards? It's like, oh, trust me, it ain't that easy. It's not just like rinsing this in the sink, man.
It's like go big or go home strategy.
There's a lot of work to do in order to get this right. And I knew there was a lot of work to do. And that's why I pushed back on it for so long. But like I said, we see more and more demand for it now. But okay, so we're not going to vapor degrease. We know that is not a path that Worthington or CircuitHub want to head down. We have a couple options. We can either switch to using organic acid for when we want to clean boards, or we can continue to use the chemistries we have been using, which is a no clean chemistry by Henkel, which is, probably, if not the largest chemical company in the world, nearly the largest. They're a massive chemical company. And we'll probably continue to use that. So that way there we have some flexibility. We can just have one process for assembly, and then we can determine if we need to clean these boards for this customer or ship them as no clean as we have been. And then we have a decision to make. Are we going to get a conveyorized machine or a batch machine? So far, spoiler alert, we're probably not going to get a conveyorized machine. But it was an interesting discussion to understand that a little bit better, if that was even an option, and what the downsides were to it. And it sounds like we have got to invest some time and energy in understanding process control, cleaning process control, and making sure we have a system for monitoring that, checking that, and then of course also coming up with, if we choose to use a zero discharge, well, that solves that problem. If we choose not to buy a zero discharge, then we got to figure out a way to manage that so that we keep everybody here in South Deerfield, Massachusetts happy. And considering we live here, we would like to keep ourselves happy as well.
Absolutely.
It is our backyard after all. Really, really fascinating stuff. Is there anything else we haven't touched on that you think might be kind of an important thing okay, let me put it this way, if I may. One thing we like to do is we like to make sure we give everybody an opportunity, such as yourself, the chance to offer advice to designers and engineers who are creating products as it relates to our discussion today. Is there something you can encourage them? Like, okay, you're thinking about cleaning. What is going to make your life? Let me put it this way. Look, I guess it's really a two-part question. First is, what makes cleaning easier? How can you design your product in such a way that it might make cleaning a little bit easier and a little less painful, and you'll have a higher success rate when we go to clean your boards? And I guess the second part of the question is, how does a person even determine whether or not their product should be cleaned besides reliability? From a design perspective, is there something about the design that is going to force them to require cleaning? And I'll challenge you on that if I disagree.
Yeah. Well, those are great questions. I wish more people asked those questions because things would be, well, maybe I don't, because if cleaning was that easy, there'd be 1,000 companies selling cleaners. I think space is always our friend. So if there are mechanical tricks to... This
is the stock answer, isn't it, Melissa?
Raise the standoff height, so to give the machine and the fluids a chance to properly impinge under there. BTCs are the bane of our existence.
Well, basically, how can you possibly clean it? There is no clearance. There's nothing to get under it.
Well, there's usually a couple mil. We can pretty much go down to a couple mil, but
it doesn't look like much.
I know. I mean, you can rarely floss it, with human hair, right? It's very, very small. But there are, we've learned, and other companies in the equipment industry and the chemical industry have learned the mechanical tricks to get that to happen. And that's where chemical becomes our friend, because chemical lowers the surface tension.
Yep.
But then you have to rinse it, with higher surface tension rinse water. So you have fat water chasing skinny water, but there's things you can do mechanically. We don't need to go down that road, but
it's like me when I go to the gym. I'm the fat guy chasing the skinny guy. I'll be one of you someday.
Yeah, I think the skinny guys are just posers. I think they're paid to just stand next to machines and look sweaty. You go in the back and have people spray water on them to make them look like they've been working out. But
so, like, when you say bottom terminated component, let's put rubber to road here. We're talking QFN, right? We're talking
QFN's
SON.
the poster child. QFN's the poster child. BGAs,
but not BGA. BGA, you've got clearance. Yeah, you can get right under them.
Yeah, BGAs are fine. But BGAs produced an inspection challenge, back in the day.
Yes.
And that's where X-ray really got its teeth into our industry. Is through BGAs. But from a cleaning standpoint, we like space, but we don't always get it, and we rarely get it. I wouldn't really go too far into recommend they change things, because cleaning is still not 100%. Not 100% of all assemblies are going to be cleaned. It's a growing percentage, but it's not 100%. And cleaning is very frequently, particularly today, an afterthought. All of a sudden, someone like yourself will go, shoot, my customers are asking for cleaners.
That's right.
And you're not going to go back to your customer. They put a bid out to 4 contract manufacturers, and one of them, yours, says, we'll take it, but we recommend that you give us 8 mil clearance on that QFN. They're going to go, nope, we're going to go with the other guy because we don't want to make any changes.
How do you change the clearance of a Q? I don't even know how that's possible to change the clearance of a QFN.
Well,
it's either on the board soldered or it's not.
Well, it's a question of raising the bridge or lowering the water. In this case, it would be lowering the water. So they can do that by routing out or changing the masking on a board. And if you remove some masking material around the part, you, in essence, give a little bit of clearance. It traps less. It allows the
Don't you dare, Mike. Don't you dare. I love solder mask. I want it everywhere I need to put solder.
Absolutely. And goes back to our fundamental of, who was it? What company was it where their trademark was do no harm?
Google,
right. I don't know if they still say that anymore, but
no, I don't think they do.
This is kind of a do no harm.
No, they were don't be evil. That's what it was. Don't be evil.
Okay.
Yeah.
Well, someone else had do no harm. And this is kind of a do no harm.
Doctors.
Yeah. They're proud of oath. I promise not to kill people intentionally.
Yeah.
So we don't want to kill people intentionally. We don't want to do things like remove too much mask, and then there's other issues. The mask was there for a reason, but there are
because we've had issues where we've had what we call gang solder masks openings, where the whole row of leads on a QFN are completely exposed with no solder mask in between them, and it creates a really cool looking caterpillar, but not a great solder joint.
Sure. Window painting, from the stencil standpoint, can help with some things like that too. But I'm not a big proponent of going back to the drawing board and asking people to change things. We in the cleaning world, we get what we get. We get all the hand-me-downs. We get because it was never designed. It was barely designed for manufacturability. It's never designed for cleanability, right? So
never.
So we just figure out a way to do it, and we're constantly challenged. The chemical companies are challenged. We're challenged, and so far, we overcome it. And some applications are more difficult than others, but there's no application yet that I'm aware of where we just have to tell a customer, "Oh, sorry, can't do anything. You're SOL. Can't do anything." So we've always been able, as an industry, to overcome those challenges. And we not only have to overcome the challenges today when we design new equipment, we have to, our goal is to have a 10-year relevancy. So we have to have a crystal ball, and we have to assume if 4 mil or 3 mil or 2 mils are the standoffs today, will one be the standoff tomorrow? And we have to design for that, as does everyone else in our industry.
Now, I guess the second question was really, okay, so I think if you have a high reliability product. It's going in an airplane. It's part of a safety system on a car. It's going inside a human body. These are super high reliability applications. But let's say, we have an interesting customer that they make they're like power supplies for I don't know. Anyway, they're a power supply for like Bitcoin mining, and it's super high efficient system that because it costs a lot of energy
type stuff.
Yeah, that kind of stuff. There's an application where they want to have a high reliability product because they want to sell it to their customer, and their customer wants to get their Bitcoins. They don't want their power supply to go down on them. But they're not a critical, like nobody's going to die if that fails on them. Right. But they might have an angry customer who misses out on thousands of dollars because it failed on them. Is this just a sort of I guess my question is it that subjective where you decide that, well, you know what? I'm willing to pay for the clean boards because I want it more reliable, or nah, if I get 5 years out of it, I'm happy with that kind of reliability. Or is it more scientific than that? Is there something more tangible where you can say, no, like you see this part you're using here, you kind of have to clean that. You can't let that go. I'm curious if it gets that fine grained, or if it really is that subjective, just up to the engineer, up to the sales team, whether or not they want to have a clean board.
Yeah, it really has to do with the life of the product, the cost of failure, the climactic and use environment the part's going to go into, the standoff heights, the component density. All those are factors that determine if cleaning is an appropriate practice.
I knew you weren't going to give me a black and white line.
Well, the problem with all answers in our industry is, the first two words is, well, it depends, right?
It depends. It depends.
So
not just a diaper company anymore.
Not just a diaper company anymore, right? Exactly. It is now the answer to any technical question. So I would say electrochemical migration, which is the reason we're cleaning, right, is to avoid electrochemical migration. Dendritic growth, which are metal crystals forming between cathodes and anodes that short out when they reach the other end. And
you want to see some really cool pictures. Look at some electron microscope scans of dendrite growth.
Yeah,
that is
scary, right?
Awesome stuff.
Scary.
Yeah,
it's like taking metal shavings and sprinkling them on your boards while they're plugged in, right? It's the same effect. And then there's parasitic leakage, which is a really insidious problem because it's temporary. It doesn't blow up the board, but it causes the board not to function properly, like it won't calibrate, but it's only temporary when the conditions
and then it goes away.
It goes away, comes back, goes away.
What about tin whiskering? Have they figured that one out yet?
Yeah, that's not a cleaning issue. Tin whiskering is another phenomenon where dendritic growth grows parallel to the board.
Yes,
tin whiskers grow perpendicular to the board. That's not the same. I don't know if it even falls within an ECM category. It might technically, but it's not something you're going to clean your way out of. It's like conductive anodic filament, which is ECM within the layers of the board. That is an ECM problem, but you can't clean your way out of it because the problem is in the layers of the board. There's a whole nother solution for that. But I would say the average ECM failure event, and there are exceptions to this, but the average are between 8 and 18 months. It will take for a dendrite to grow. They don't grow fast, right? And they only
surprised. I'm surprised it's as fast as that.
Yeah, well, it could be longer and it could be shorter. But
like I've got a Apple display sitting in front of me, not an iMac, but just one of their displays. So it was manufactured in 2008. Works great, absolutely beautiful. But then again, it has sat in a room that goes from 67 to 72 all year and doesn't get wet.
Get outside in Massachusetts in August, right? And it'll last one season, right?
Yeah.
I have a saltwater
it's
pool.
pretty comfortable in Massachusetts in August.
Okay, well,
I get your point.
Yeah,
I get your point.
Make it
How about February?
February, yes. I have a swimming pool in my backyard. It's a saltwater pool, so we have a salt system, which just basically salt turns to chlorine. So that's all.
Understood.
And I have a controller outside, and I've replaced the salt cell controller 3 times in 11 years. 3 times. And each time it's been dendritic growth. And of course,
no kidding.
This is a consumer part. No one's going to die, right? If the salt system fails on the pool. You just have to throw chlorine in it. No big deal. And so, I've contacted the manufacturer and I've told them what the problem was, and they don't really.
I'm sure they love to hear it.
Love to hear from me. It's like, you have an ECM issue. But, to convince them to change it, to start a cleaning process when their part is not critical.
Is it Hayward by any chance? Is it Hayward?
It is. Yes, it is Hayward, as a matter of fact.
So those are made right in Rhode Island. They have their own manufacturing operation, and no, they do not clean.
Yeah. And I can see from their standpoint, there's no clean. We're a consumer company. They are at best class 2, at best, maybe even class 1. But certainly
at that volume and for that application, they're going to be class 2, but they could probably be borderline class 1.
Exactly. Yeah, I mean, it's not an alarm system. It's not. It's stuff that can fail and no one's going to die. So,
like, have you ever taken apart, like, I've had to repair like my stove before and fridge and stuff like that, washing machine. Those boards, like, I don't even know how they can call those class 1. those things are like class half.
Yes.
Like unbelievable. I'm like, I can't believe. I mean, I know the margins are razor thin
Sometimes
on appliances.
No masking at all. Right?
Oh my gosh. It's exactly.
It's like,
I look at
it's like phenolic and wire at the other side. I mean, that's what
it blows my mind because circuit boards are so cheap and yet they found a way to save 25 cents. Yep. It's like, oh my gosh, this is unbelievable.
Well, you talk about saving 25 cents. You know, a lot of the obstacles to cleaning, I think universally people will agree a clean board is more reliable than a dirty board, right?
Mm-hmm. Sure.
Unless, like in your case,
properly cleaned board.
Exactly. Thank you.
Yeah.
You drank the Kool-Aid and it's starting to show. One of the obstacles that a lot of people will be so resistive to cleaning, they would rather fix boards and replace boards than prevent the problem to begin with because they think that there's a big barrier and they think the barrier is price. The average cost on a batch machine, not an inline, that's a whole different animal, but on a batch machine, pretty much regardless of whose brand of batch machine, the average cost...
Hang on, let me make sure I'm sitting down. I want to faint.
5 to 7 cents a board.
What?
5 to 7. And if you factor
this is,
in...
Dear listener, we are going to charge you more than 7 cents. I promise.
Exactly.
Be prepared for that.
I'm not counting labor.
Okay.
And I'm not counting the price of the machine. But if you add in a 7-year depreciation, IRS scheduled depreciation on a machine, it's going to be a little bit more, but not much. The point being, it is not anywhere near the most expensive, part of your process. And it is the one part of the process that is only done to improve reliability. You don't use your printer to improve reliability. You use your printer to get the parts on the board. You use your reflow oven to reflow the solder paste. You use your...
That is so true.
AOI, okay, AOI is maybe less accurate, maybe less reliability, more accuracy, which could be reliability, but
it's process control.
Right, but cleaning is only done to improve reliability. That's the only reason one would clean. And if you don't have to improve the reliability because you're reliable enough, you don't even need to clean. So it is a 100% reliability enhancement tool. That's all it's for.
That is, I can't even tell you how much I've enjoyed this conversation. Like it has just been so like I've never even thought about that before. I've always just thought about it like from it's an aesthetic thing, and it's a reliability thing, but sometimes it's necessary. But you're right, it is a reliability process.
Yep.
It is a process to improve. I guess one process that you could lump into that would be conformal coating, right?
Well, yes,
that's about reliability.
One should clean before the conformal coat, but you'd be surprised how many people don't.
No, we have plenty of customers that request do not clean and do conformal coat, and that is what they want.
Right.
Yeah,
that
is what they want.
Which is crazy, but not that.
Hey, don't call my customers crazy.
Your customers aren't crazy. The concept is a little crazy, in that what people don't realize is their intentions to conformally coat are good, right?
Yes,
they conformally coat to keep bad things off the surface of the board. What they don't,
but they've already got bad things on the board.
They've created this sarcophagus.
Sealing it in.
They have King Tut buried with all his possessions, and this is a case of all the bad actors being put in one jail cell and the door locked, right? What people don't realize is conformal coating, it takes 3 things to form ECM. 3 things. That's all. It takes an electrical bias, which your customers provide the moment they turn the switch on. It takes a conductive residue, and it takes moisture. Take any one of those 3 out, and you'll never have an ECM issue. So you can solve ECM by not giving it any power, but that's the E in ECM. Obviously, that's not a good solution.
I think that'll work. Yeah, I think that'll work.
The board will last forever if you never turn it on. Right? It's like a lifetime guarantee. Just never turn it on. Turning it on voids the warranty. The other is to prevent moisture. So a lot of people go, well, you can have a lot of residue. If you don't have moisture, you don't have that catalyst to form ECM. So what a lot of people will do is say, well, I'll conformal coat my boards. That will protect it against moisture. It doesn't. It protects it against fluids. All conformal coating materials, from acrylics to parallenes, are permeable. They all have a membrane structure.
Paralene.
Paralene, it'll totally let moisture through. Not enough to create a short. That's what if I take my big drink right here and I pour it over my MacBook Pro would be toast. unless it was conformally coated. If it was conformally coated, it would protect it. But conformal coating protects against droplets large enough to create a short. It does not stop moisture from permeating through. And, we have on our webinars, we show this all the time. We have photographs of dendrites growing under conformal coating. And that could not happen if there was no moisture. So
great point.
Coating to avoid cleaning, it's a failed logic. And B, even if it was a good logic, the best practices for conformal coating is to clean before you coat. So if you're cleaning to do conformal coating to avoid cleaning, then circular logic works because circular logic works because circular logic works.
Funny. I like it. You've given me a lot to think about. This has been enormously educating for myself. I hope it has been for the listeners as well. I'll repeat this until I'm blue in the face, but I love peeling back the curtain of this operation and how we get things done that we get done, and helping customers to understand really the details of what we're talking about when we talk about what it takes to clean a board. It's not just as simple as dumping it under the sink faucet. Like, it's going to take some work. It's going to take some equipment. It's going to take some process control. It's going to take some chemistry, floor space. And that's why we can't charge a nickel a board. There's all these other things we have to manage. That nickel a board is just to pay for the machine, not for the people, not for the chemistry, not for the water, not for the energy, not for the floor space.
And you're paying for that machine whether you're cleaning in it or not that day. But
that's right. And you better keep it running. You better keep it full. Otherwise, it's going to be 25 cents a board just to pay for the machine.
Well, what you are selling, the service that you're providing, is enhanced reliability. That's right. There are 1,000 things that'll kill a circuit board. One of them being electrochemical migration. You can take that 1/1000th off the list. And
I love it.
Now they only have to worry about 999 other things.
Tin whiskers and
lead corrosion and whatever, right? Or tombstoning
intermetallic joints that fail from copper dissolution and lead-free alloys.
There's plenty of other things to keep you up at night, but we can at least take this one off the table. This is an easy one.
And if you want to hear about more of those things, Mike again has an excellent podcast called Reliability Matters where they discuss such things.
Good segue.
Hey, look, I'm being a professional someday.
Absolutely.
Someday,
now, I think you are now.
my absolute most favorite part of the show, and I apologize, Mike, I did not prepare you for this, but I think you're nimble enough on your feet to handle this one. I have lots of pet peeves. There's so many things that just don't make sense to me and just drive me crazy. And I love to complain about them. In fact, Melissa and her partner bought me a T-shirt that said,
like member of the Piss and Moan About Everything Club.
That's it. That's me. That's me. Right. Nothing in this world is so perfect that it can't be improved. And that's what I think pet peeves are really the result of. Isn't that right? We're just trying to improve the world. That's all it is.
Yeah.
But we invite our guests to share their pet peeves. Like what is it? It doesn't have to be about circuit boards. It doesn't have to be about our industry. It can be about anything. For example, one that I've shared regularly is the lack of use of Oxford commas. Drives me crazy. Drives me absolutely crazy.
Yes. I have people tell me I'm wrong. And you're talking about when you say this, comma, this, comma, this, comma, and they will not put the last comma on there.
That's correct. Right. That's correct. Because they read an article or they were taught in grade school that you're not supposed to put the comma before the second and, but there's a big difference between having grandma for dinner and having grandma for dinner. I'm just saying.
Yes. I do have pet peeves, and they're kind of all over the map.
Can you share one?
Oh, sure. I'm a grammar Nazi, so I don't like
they
when
always
people
come down to grammar.
Get grammar wrong, or they make up words like supposedly. Right?
Oh.
Like, I can't stand that. I also can't stand when people go, I could care less. No. No. It's like couldn't care less. I couldn't care less. I care, right? It's like
yes.
So think about the words you're saying. And I also can't stand it when the plane reaches the gate and everyone stands up.
It drives me crazy. That drives me
nuts. Yeah, that's right.
You know what? I have been watching
in the aisle seat, and the two people to the left of me or to the right of me, are mad at me because I'm not getting up. Like,
right.
I'm not moving anywhere for 20 minutes. I'm going to sit right here. But
that's right. That's why I'm a window seat man. I take my time. I will sometimes wait till like everybody's off the plane and then nobody's rushing me because if I don't have another plane to catch.
See, I can't do window seats anymore. I used to all the time because I also gives you a place to put your head against something.
Exactly.
But you get to my age, you have to go to the bathroom all the time. So it's like I plan my seat, strategically to the toilet. Right? I want to sit on the aisle. There. I also want to make sure that there's not going to be, statistically speaking, a beverage cart between me and the bathroom at any given moment. Yeah. So I fly up front a lot now. I've got a bazillion miles that I've earned over my lifetime. And so I always fly first class using my miles. And the best thing about that isn't the wide seat. It isn't the warm, peanuts. It isn't the drink while you're taxiing for takeoff. It's the fact that there's only 8 people sharing one bathroom, and I can always get there. That's what's important to me at my age now.
I appreciate that.
And you'll get there.
I appreciate that. Well, I think I shared one recently. Did I share this last week? It's similar to your supposedly and your I could care less. I shared, at least I think I did. The one that drives me crazy is when people say irregardless.
Irregardless, yes.
Yeah.
Rather than regardless, yes.
Or irrespective. It's like either use irrespective or use regardless.
Yes.
Those are real words. Irregardless is not a real word.
Yes. I'm terrible with that. I also hate when people end a statement with a question mark. I hope you're doing well today, question mark. That's not a question. Are you doing well today is a question. I hope you're doing well today.
Wait, so you're saying in text form?
Like in an email or something.
In an email.
They would put a question mark after that?
All the time. I hope you're doing well today, question mark. It's like...
That's insane.
Just inflect.
Who would do that?
Do the inflection and it doesn't make sense. I hope you're doing well today. Say it as you're writing it and you'll realize it doesn't make sense.
Oh, that's great. Well, okay. All right. So we've poor people with poor grammar. I feel like we're picking on them too much. Is there any industry related pet peeves you have that you might want to share?
Yeah. Well, yeah. People who want to clean misprints in their board cleaner.
Crud. I want to do that.
Are looking, nope. Don't do it. Buy a stencil cleaner for your misprints or stencils. Buy a board cleaner for that. And there are plenty of companies out there that'll tell you that you can do it in one machine, but you're in for trouble because when that water hits the misprinted paste, it solubilizes the flux component, and all those millions of little solder spheres, those hundreds of thousands of solder spheres, go everywhere.
What about just like a pre-wipe? Get mostly off and then finish it in the machine.
Yeah.
Still not great.
No, not at all.
Okay.
I remember once going into a customer, their solenoids were clogged. They were leaking. The diaphragm wouldn't seat properly. They were allowing water to get by under pressure where it shouldn't have. And that's a tell. That's a tell, right? I'll bet you they've had solder paste in there. And because the spheres don't solubilize, they stay metal. They go everywhere. And
that's right.
Kind of like hardening of the arteries, right? You eat those Doritos breakfast, lunch, and dinner, it's going to look like your board cleaner after you've cleaned stencils in it or misprint. And so I went up to the machine and I just took a piece. I asked them, "Do you have a tape dispenser? Like just a regular tape dispenser?" And like, yeah. So I took a piece of clear tape and I just matted it on the floor of the chamber, the cleaning chamber.
Oh no!
Like a sticky brush. And then I said, "Can I borrow a scope?" And I turned it upside down and I put it under a scope. And of course, there's thousands of tiny little solder spheres, sticking to the tape. And I'm like, okay, someone's been cleaning this. These aren't solder balls. Solder balls are huge, right? But this is just solder paste, right? Spheres.
So what makes a stencil cleaner different that it can handle the little tiny solder spheres?
Because all it's seeing is stencils, and it's not worried about a rogue bit of solder paste making its way under a component on an A side when you're doing a B side misprint. So imagine, you don't always make mistakes on the A side. You make mistakes on the B side as well.
Sure.
So someone's got a reason to reflow a B side, or there's components on the other side that's already been put on. And the spray and air systems hit that paste that dissolves the flux component, and these solder balls are just flying everywhere. Some will get into vias. Some will go down a via. Mm-hmm. below a component on the other side, they're going to get everywhere. And some are not going to make it into the drain and into the filter. They're going to hide out in the crevices of the machine. So the next time you put a bunch of assembled boards in there and do a regular cleaning process, they're going to dislodge and they're going to find their way onto a board. That's the main problem. And so I don't like, there are certain things that are designed for certain applications. And if you use it for another application, it might work a time or two, but then you don't want to go back to the original application. I don't want to take a shower where an engine was cleaned in it, the day before, because it's just going to leave grimy residue that it's going to get on me next time.
That's a good analogy.
I think boards should be cleaned in board cleaners, and stencils and misprint should be cleaned in stencil and misprint cleaners. Don't mix the two. And
very good.
I'm speaking as if everyone has all the money in the world. So I'm not saying it's the financially the cheapest way to do it, but when you factor in failures that can occur by commingling two polar opposite applications, then it is probably the cheaper way to do it. But from an equipment standpoint, keep them separate. And don't wipe a board. Wipe a stencil. Absolutely, wipe a stencil before you clean it in a stencil cleaner. But don't wipe a board, because you're going to end up basically pushing some of that paste down a via.
Oh, you absolutely are. Yeah. And I guess my hope was that it would extract that from the via, through the cleaning process. But maybe not. I guess maybe not. Huh?
Oh, you'll clean out it. Yeah, you'll clean it out. The problem is while things are all flying through the air, this chaos of all these thousands of solder spheres just flying around may lodge themselves in an area that can't be cleaned, because we rely on whatever we're trying to remove that's under a component to dissolve and go into solution. We don't have to force a metal ball out by just sheer pressure, because we might be pushing it against a dead end, right? And all we're doing is lodging it further. If it dissolved, it would be cleanable. But if it doesn't dissolve, the cleaning process is not meant to remove anything that doesn't dissolve. It might knock off a solder ball, but it's not going to dissolve it, right? It might just
it's going to dislodge the solder ball, because the solder ball was only there because it was stuck there by flux. That's right. And since we've dissolved the flux, it's going to fall off just because gravity.
Right.
Yeah. All right, Mike, thank you so much for being on the show.
Thank you.
I have so much appreciation, gratitude for this. I've thoroughly enjoyed it. If you ever need like an unbelievable dummy on your show, I am happy to oblige.
I would love to have you on my show.
Yeah.
as a contract assembler, I haven't. Have I had any contract assemblers on my show? I don't think so. And that's on my list.
It's because you've got nothing but doctors on the show. When you get the associate's degrees like me, it's like, what are we going to talk about?
Funny, on another show, Concept to Creation, which is the brand new show, talks about entrepreneurs in the EMS space. I interviewed someone on my first episode that got his associate's degree at 13.
Oh,
13. Wow. We all think we're smart people until we talk to people like that, right? And then he got his bachelor's in engineering, and then his master's in engineering, and his PhD, and then went back for an MBA. And I wanted to call him Doogie Howser, but I don't think that would have gone over well. But
when are you going to make something of your life?
Yeah, exactly. I'm like, total underachiever. But no, very impressive resume. But by the time you get to my age, and you're still in the time of your life when your experience matters as much as your education. When you get a little past that, it's really more about experience than education. Because I'm a college dropout. I didn't even stick around for my AA. I got like a lowercase a single lowercase a, supposedly, but I could care less.
I think that's how we end the show right there, Mike. I think that was. Well, you got to hit your soundboard. How are you missing that one? That was a perfect opportunity.
Well, we could do that, or we could just do the bada bing.
Oh, that's it. I love it. Come back anytime, please. If you're in the New England area, I don't know how it's working yet. For a long time, we were not allowing anybody except for necessary person. Like if you were fixing a machine, you were allowed in the building. But if you were just trying to sell something, even though we have to buy things, we weren't allowing sales.
I think it's essential repair people or podcast hosts.
That's podcast hosts. I think that's but please, if you're in the New England area, please stop by. We'd love to host you and show you around a little bit. And just thank you a million times. If people want to ask you questions, I know you're prolific on LinkedIn, but are you on Twitter, or do you post anywhere? Do you have conversations with people? What's the best way to get in touch with you?
Well, if you do LinkedIn, it's M like Mike, T like Thomas, Konrad with a K, MT Konrad. On Twitter, it's Mike Konrad. The best email address, I have a million email addresses. The best one to get me at is mike@mikekonrad.com. That's Konrad.
Oh, there you go.
And the company is Aqueous Technologies. But feel free to reach out to me directly at mike@mikekonrad.com. And I'll be happy to answer any questions I can. And if I can't, I'll point you in the right direction.
Unlike certain hosts of the show who shall go unnamed, myself, Mike actually responds to his emails. So, feel comfortable to reach out to him and pick his brain as much as we have already today. Yes, I'm sure he won't mind it at all.
Absolutely.
As always, you can email us at contact@pickplacepodcast.com, and you can tweet at us at CircuitHub or at W Assembly.
Thanks for listening to the Pick Place podcast. If you like what you heard, consider subscribing in your favorite podcast app, and please leave us a review on Apple Podcasts or wherever you get your podcasts from.
Thank you so much, everybody.
Well, that's another episode. Thanks for listening to part 1 of this 2-part episode. Thanks also to Chris Denney and Melissa Hough of Worthington and CircuitHub, respectively. Check out the Pick Place podcast on Apple Podcasts, Google Podcasts, and many other podcast sites. And while you're at it, be sure and subscribe to the Reliability Matters podcast, also available on Apple Podcasts, Google Podcasts, Spotify, and virtually wherever you get your podcasts. We release new episodes on the 2nd and 4th Tuesday of each month. Also, be sure and check out our newest podcast, the Concept to Creation podcast, where we have conversations with EMS industry entrepreneurs about their journey into business. They discuss their successes, failures, challenges, and inspirations, and provide advice for budding entrepreneurs. These are fascinating conversations with the leaders of our industry. We release new episodes of Concept to Creation on the 1st and 3rd Tuesday of each month. Thanks also to Circuit Assembly's PCB Chat at pcbchat.com and Ascendo Reliability's reliability.fm for syndicating the show. Until next time, stay safe, stay healthy, and stay happy, and keep doing it right.
Thanks for listening to the Reliability Matters podcast. Join us on the 2nd and 4th Tuesday of each month for new episodes of Reliability Matters.